Right. Another cool and common thing you'll see with ethers are what's known as crown ethers. So we'll go ahead and just draw the structure, right? These two are obviously two carbons right here, and then we have two oxygens, and then we just go around in a little ring. Right. And so we have a whole bunch of oxygens pointing towards the center. They, of course, have lone pairs, and then these lone pairs can coordinate with various types of metals or other cations, right? So we'll put M plus and draw little dots here indicating that they're kind of coordinating with them, right? The metal's positive, the oxygens are negative, they like each other. And so what these crown ethers do is they bind metals. So for example, you'd like potassium, lithium, and other metals too, chromium, all kinds of stuff, and other ions as well. So not just necessarily metals, but anything really with a positive charge can fit into here. And these are really useful because they can help you dissolve ionic compounds in non-polar solvents. So like say you want to use benzene as the solvent, but you want to use potassium as some kind of reagent. K plus is obviously not going to dissolve in benzene. So you can add some crown ethers to help dissolve it. And there's all kinds of other cool chemistry that you can do. So this is just one example of a crown ether. You can have all kinds of crown ethers. So this is what's known as a 12 crown 4. The 12 corresponds to the number of carbons and oxygens combined. So in this case, there are 12 carbon and oxygens combined. And then the 4 stands for just how many oxygens. So in this case, there's only 4 oxygens, right? So you can have all kinds of different crown ethers, for example, 15 crown 5, or maybe 18 crown 6 type of thing. But it always goes carbon, carbon, oxygen. That's the theme here. This lets you dissolve ions in non-polar solvents, right, which is very useful. This is also the kind of origin of what's known as host-guest chemistry. Right, so in this case, the host is the ether, and then the guest is the metal. But really what we're talking about here is binding ions in some kind of host. And there's a lot of applications for this and a lot more complex molecules for this. So now we've gotten to the point where we're basically making synthetic cell receptors, right? So think about a cell, it's got a lot of host-guest chemistry there. Here we make, artificial ones and modulate them for our needs.